16.7 The Scanning Tunneling Microscope and the Atomic Force Microscope. Let's look at the diagram of the STM, Scanning Tunneling Microscope. This is a metallic tip. It scans this surface without touching the surface. Electrons may escape from the surface and form an electric current here. How is that possible? Tunneling effect. The electrons may pass through this classically forbidden region and reach the tip. In this region, the kinetic energy of the electrons are negative. Now if we scan the surface from left to right, over here we see fairly strong electric current, and over here fairly strong electric current. For two reasons. One, these two atoms are different from the pink atoms, that's one. And two, the distance between this atom and the tip, or the distance between the blue atom and the tip, are shorter than the distance between the pink atoms to the tip. So this electric current is stronger when the distance is smaller. Same here. And now if we compare this two, I'm guessing the electrons can escape from this blue atom more easily than from the green atom. So let's say this is sodium and this is platinum. Electrons can escape from a sodium more easily and then generate a stronger electric current here. The tunneling probability is proportional to e to the power of negative 2 kappa x. So again, the distance between the tip and the atoms is very important in here. Over here, this is a more comprehensive diagram. Again, you have a tip, you have a sample. The tip scans the surface of the sample, and the electric current is recorded over here. And this is the amplified tip and the surface. If there's a different kind of atom on the surface, it can be detected because this electric current will be different than between the dark blue atom and the tip.